Hello and welcome back to the channel. And today's episode is a little bit different. It was requested for me to revisit the Tetris tutorial, as there was one slight issue that we left out, and it was that there was a problem with the code and with our game when we're trying to clear multiple lines at once. And to be honest, the code for clearing the lines was a little bit complicated and convoluted. And as I was reading it, I thought to myself, if this is so hard to read, write, and understand, then the problem is definitely our approach and our mental model of clearing the lines. And today I'm going to show you how we can change the model, the approach that we use to make it better and make it work. And this is true for all of the programming. If something is really hard for you to conceptualize and implement, that means that maybe you should take some time off and rethink your approach. I had a friend at one project that whenever he solved any kind of issue, he would immediately start thinking about how to make it better, even at the cost of rewriting the whole feature. So let's see how it works for now. I changed the code a little bit, so it only spawns I tetrominoes, so it's easier to test. And as you can see, now we have no issue when clearing multiple lines. Let's see how it will work now. It should left out only this. Maybe let's add this to, yeah, you can see it is clearing multiple lines correctly. So let's jump into it and let me show you how it's done. So let's start. We will be adding and removing some things, but we'll be changing our approach. So basically, let me use the best tool in the world to show you everything that's going to happen. All of what will happen when we lock a tetramino. Before, we would just track all the tetraminos on the board and then decide which cells belong to which line and do some strange calculations. But I thought that this is not the right approach, because after we lock the tetramino, we don't really have to work with tetraminos anymore. What we are really interested is the lines in our board and whether they are full or not, and the cells within that lines. So we will construct a new scene, call it line, and we will add the pieces to that line, and we will check whether the line is full, and if so, we'll remove that. There will be some additional things that we need to do around this, but we will not be concerning ourselves with tetraminos anymore, as they're not really the proper model for what we'd like to do. We don't want to clear tetraminos, we would like to clear a full lines. Therefore, we'll construct one. Okay, let's get to it. So what I'm going to do is I'm going to create a new scene, and it's going to be a 2D scene, and I will simply call it line. Let's save it into the scenes, and we'll add a script into the scripts. Perfect. Let's get rid of everything and let's fill our class. We'll give it a class name of line. We will provide the max count value here, and we'll use this to check is line full. We could also, now that I think of it, what we could do is we could pass the max count here and just do return max count is equal to get child count. The only children we'll have here are going to be pieces belonging to that line. Okay, we need to go to our board, and first and foremost, let me run the highlight here so that you can see what I'm doing. We will remove some stuff that we don't need, and we don't need move all row pieces down function. We won't need a clear row function. We don't need clear board pieces, and we don't need fill board pieces, and we don't need clear lines anymore. Okay, so there are some different things that we need to do when Tetramino is locked. Okay, let me see. We do not need to clear the lines, but we'll need something else. Let's start by doing a new function, and we'll call this add Tetramino to lines. We'll pass the Tetramino there. So let's do pass right now, and let's do it right here. Add Tetramino to lines, Tetramino. And we know that this is of type Tetramino. Cool. First thing we're going to do is we're going to obtain the pieces of the Tetramino. And we'll just filter in the children. So get children, filter, we'll do inline function here. Okay, so we can filter out the timer. And then for each piece in Tetramino pieces, we'll try to either find a line for it or to construct a new line. Because let's get back to our paint. If I look at Tetramino, oops, if you look at Tetramino that is of that shape, for example, right? And before you had some pieces, let's do it like this. In that line, we already constructed that line, and we know that those pieces need to be added to already existing line. But for those pieces, if we didn't have any line before, we have to construct a new line and add those pieces to a new line. Okay, so first let's obtain the Y location of a given piece. Or better is Y position. This is piece global position Y. And let's check where line does line for piece exists. And we'll assume at the very start that it doesn't. Okay, but it will change. Var, of course. Then we need to obtain our lines. And we'll do for line in, and we'll write a function to obtain the lines. So function get lines, return get children. We will we are in a board right here. Where is it? Main board. So the lines will be children of our board, which makes sense because we put them in the board, right? So what we have to do is, again, we will have to filter true right type. So let's return child is line, but there will be no other oh sorry, C. There will be no other children, so probably just doing get children would be fine. Okay, you can go back here and we can say for line in get lines. Okay, and we check if line global position y is equal to y location, then we know that this piece should now belong to that line. And currently that piece is a child of the Tetromino, which we're locking. We add some space here. So what we'd like to do is actually reparent that piece and make it a child of that line. And thankfully we can do that in Godot rather easily. We can say piece reparent and pass a new parent. And then we can say line, does line for piece exists? Yes, because we found one already. Y position, of course. So we iterate each piece in Tetromino, and then we iterate each line and search for a line that has the same Y position. And if we found one, then just say, okay, cool, this is a new parent for our current piece. But at the very start, we don't have any lines created. So that check is going to fail, right? So after we iterate through all of the lines, which by the way, for starters, that's going to return empty array so that for loop is not going to run. Then you say, okay, the line for piece does not exist. Then we have to create new line. So what we have to do is to get ourselves a reference to the line scene. So already var line scene is equal to preload line tscn, and then I can say if it doesn't exist, we can simply instantiate it. So piece line is equal to line scene instantiate as line. Okay, and I can say piece line global position is equal to vector2 0 and y position. So we place it at the location of a given piece, and therefore if we will be checking that line which we now created for other pieces, it will match, right? So we set the position of that line to that value, so it will match when we're iterating over next pieces. Then we add child piece line, and of course we still have to do our reparenting. Reparent piece line. Okay, perfect. And that's gonna create our lines whenever we add Tetromino to a line. So let's see what will happen. I'm going to lock Tetromino. Let's maybe lock another one, and now we should have, based on what's here, we should have 2 lines added. So let's go to remote, let's go to main, find a board, and we can see that I have a line with 1, 2, 3 pieces, and this is also another line with 1, 2, 3, 4, 5 pieces. So let me check if that's correct. If I could just show that to you. Well, that's because we're paused, right? So 1, 2, 3, 4, 5 pieces and 3 pieces. So this seems to work. But that doesn't mean that we can clear our lines. So again, to test that more easily, let's go to piece spawner and change some stuff. I'm gonna change it for now to only give us I as a tetramino. Okay, because now if we try to clear the line, and as you can see also our ghost tetramino hard drop doesn't work anymore, nothing's going to happen. So also we have to rewrite the logic in our board to do the hard dropping and also removing the lines. So let's go to on tetramino locked, and we do add tetramino to line, and I'm also going to do a new function and call this remove full lines. And let's start working on that. So let's go here. I'm going to say to remove full lines, we have to iterate through our lines. So for line in get lines, for line in get lines, we pass that if line, and we have a method for that called isLineFull. Let's go to back to board, isLineFull, and you pass the max columns, I believe, column count, sorry. We will do two things. We will call another function called move lines down. We'll pass global position y here, and we'll call, for now let's do this. Move lines down doesn't exist. So basically we'll write a function that's gonna get a line of current position and check and basically move every single line above it down as one step, right? Because if you remove one line, all lines should fall down one row down. So move lines down, let's say y position. Again, we have to obtain our lines. So for line in get lines, what we'll do is we will just say line global position plus equals 48. Okay, and that would be almost correct, because what we have to do is only move the lines that are above the y position. So if line, let's see, global position y is lower than y position, we'll do that, right? Because we might have a situation, right, where we have like, or maybe let me show you that in a game. You can construct something like this. Oh yeah, and also the detection doesn't work anymore, as you can see. So also something we have to fix. So maybe let's handle this right now. So let's leave that for a moment. what you can see is that the collision between the tetraminos doesn't work anymore, right? Which is very bad. And this is because our tetramino gets something called other tetraminos, which for now is simply empty, as we don't change that anymore. Okay, so we have to change the data we're passing there. So let me do something like, let me check my notes. Oh, here we can say that instead of accepting other tetraminos here, our tetramino is going to get other pieces instead. Right, can we type it? Or we can call this other tetraminos pieces. Okay, and then we can use this when we are doing our collision. So let's find our collision function, which is here, and then we can just remove that and remove that and unindent that and say that we don't have to worry about tetromino pieces because we're working with other tetromino pieces as a whole. And then we have piece in pieces and tetramino piece. And then here, I don't care about tetramino anymore. I just care about tetramino piece global. That was tetramino position. So here it's gonna be tetramino piece position. Okay, so we have to do a little bit of changing here. Where is it? Yes, so instead of passing an array of tetraminos, we're passing the array of every single piece in our board. So we have to construct it now. So going back to our board, here we don't have other tetraminos anymore. We have other tetraminos pieces, right? And to pass that proper value there, we have to obtain this. So let's create a function. I'll call this other pieces from get all pieces. Okay, and we can pass it here. So let's write that function. It's going to be rather simple. We have to iterate across all of our lines again. So get all pieces. That's going to be an empty array in the start. And we will just get all lines. And we will just append line pieces. So pieces, append array, line, get children, right? So because our line, let me add this. Our line has only pieces as children. We get these children, and we append an array because this is an array. So we're adding array to array. Don't mistake that with append, which appends like a single value. If you want to connect two arrays, you should use append array. And we return that. Those pieces. Perfect. With that done, our collision should work again, I believe. So let's check that. And it's still not working. Okay, so what did I miss? Other pieces, we pass this, then we have other tetramino pieces. What am I missing. Let's go into Tetramino. Oh, I know where we have a mistake that prevents us from calculating the collision property. It should be global position, of course. So here in is colliding with other tetraminos, at the end tetramino piece should use global position for that comparison. Let's try this now, and you can see that not only our ghost and hard drop are working properly, we are able to properly do our collision detection. Okay, so what is left for us to do still is going back to a board. Okay, and let's for now, yes, what we should do is we should move everything down, and then when we remove the full lines, we're actually not removing them, not really, right? But let me check one thing first. If that causes the problems. It may, but what we have to do is to really remove that line. So we could call QE3 here, but there's a problem with that. You see, the spawning of the next tetramino and all of the calculation for our pieces, especially here when we're getting the other pieces, depends on current set of lines, right? So if we don't free that line immediately, like we would like to, then this value is going to be incorrect. It's gonna have too many pieces, right? Because there are also pieces that will come from the line that does not yet get freed. And this is because many things in programming are actually asynchronous. QE3 name suggests that freeing the node is actually asynchronous operation, and Godot as an engine by itself decides where it has the time and capability to do that. And this is kind of not what we wanted, even though by default we should use Q3 to destroy the nodes, right? We would like that node to be destroyed immediately because the next calculation that we have to do, which is get all pieces, is dependent on that. So instead of QE3, this time only we'll use free, which is forces the node to be freed immediately. Okay, let's try that again. So let's create that, and we can see this is being handled properly. Okay, what about let's restart. What about two nodes in a two lines in a row? Correct. Okay, so now you can see that we're still able to clear the lines properly. Let's try 4 lines in a row. Should left only this square. Perfect. So this is how we can clear multiple lines at once. Okay, and now we can go back to our piece spawner and return it to random values and try and play our game a little bit to see whether we are able to work with our new wonderful code properly. So let's bring that down. Okay, and let's drop that. It was a single line. Let's try to do multiple at once. I would like to have a situation where we clear like the first and the third line Not sure whether we will be able to do that, but maybe. We're just waiting for that eye to spawn. Come on. Okay, the game obviously hates me. No, not here. Oh, here comes the eye that we need. And if we place it here, we should clear those two lines and this one line. This second line should stay, and then we should have next line. And I believe we have a success. So this is how we can do it. The only problem left for us to solve that we can have is to read the game over situation, right? As you can see, it's not been reading properly because in our board, our game over check depends on tetrominos, right? But what we would like to do instead is go through all the pieces, right? So as you can see, we're iterating through pieces here and then here, but instead what we can just say here, 4 pieces in get all pieces. So let's do that very quickly and check where we have game over. And yes, we do. Okay, so this is very quickly how we revisited this Tetris tutorial to fix some issues. As I'm preparing this tutorial, they're taking a really huge amount of time. The preparation of a video that you see on the screen, for example, for 2 hours can take up from 12 up to 20 hours. And it's a complex process, and sometimes there will be some bugs, sometimes maybe not functionality will be working properly. As I always say, this is not a complete game by any means. This is just a blueprint for you to show of what Godot is capable when it comes to cool arcade-ish games, maybe somehow in this cool retro style. But I'm down for revisiting some videos from time to time to fix something or maybe introduce new functionality. So here we go. Thank you. Please, if you have time, subscribe, like, and comment. That really helps me beat the unfair YouTube algorithm, and I would really like this channel to grow and to provide more tutorials and more explanations for you. I'll see you in the next one. Goodbye.